In day 6, we'll practice graphing linear inequalities. So just to review from yesterday, to graph an inequality which has more than one answer, the first step is get y by itself so you can figure out what is the slope and the y-intercept. So we'll use those to plot or graph a few points, and then we'll connect them. We'll look at what inequality is being used, and depending on that, we'll use a solid or dashed line. And then we'll pick a point test and shade it to see, all right, where are all the answers? Are they going to be above or below the line? So let's take a look at the first example. If you notice here, y is already by itself, so we're already done with step 1. Step 2, identify the y-intercept, and that's the number by itself, and so here the y-intercept would be -4. So start at 0, 0, the origin, go down 4, and then make a dot. The slope is the number next to the x, so it's positive 2/3. So what that means is we're going to go up 2 to the right 3 and make a dot. I like to do it a few times, even though you only need 2 points to make a line. So that is step 2. Step 3 is a line solid or dashed. If there's an equal sign, so less than or equal or greater than or equal to, that is going to be a solid line because that means the answer can be on the line. And then if you have an inequality without the equal sign, it will be a dashed line because your answer is going to be above or below the line, but not on the line. So in the first example, there's an equal sign there, so we're going to have a dashed line or solid line, and it means our answer can be on the line. And the last step is to pick a point, test, and shade. So all of the answers are on the line. For this one, in either above or below the line. You can kind of take a guess because y is less than or equal to 2/3 x minus 4. But again, you're going to pick a point and test. And you can pick any point not on your line to test. I like to test 0, 0 if it's not on the line because it turns things into zeros and then just makes it's faster to solve. So let's plug in 0, 0 for x and for y. And so we have 0 less than or equal to 2/3 times 0 minus 4. And what happens is the 2/3 times 0, that just cancels, or it turns into a 0. So you have, is 0 less than or equal to -4? Is that true or false? If it's true, you shade the side of the line that that point is on. And if it's false, you shade the other side of the line. And 0 is not less than or equal to -4. So this is false. So if that's false, it means that this point doesn't work, and none of the points on that side work. So we're going to shade everything below the line, because we want to know where y is less than or equal to 2/3 x minus 4. So what that means is any point on the line or underneath the line, if you plug it into the inequality, it will be true. Let's try the next one. Again, notice y is already by itself, so we're done with step 1. Step 2, we're going to start with the y-intercept, and the number here by itself is 5, so count up 5. Make a dot. Here the slope is -1/2. Notice there's the x there, but if there's not a number next to the x, the invisible number is 1. So this is -1/2, which means we're going to go down 1 to the right 2 and make a dot. I'll do it a few times. Down 1 to the right 2. Then we look at the inequality. There's no equal sign. So what that means is our answer can't be on the line. So to show that, we're going to make a dashed line. All right, so now our answer for y is greater than 5 minus 1x over 2 is all the answers are either above or below the line. You pick up point, test, and shade. I'm going to guess that all the answers are above the line because this one is greater. But let's plug in 0, 0 to test. And my guess is that this would be false, that this wouldn't work. So let's try it. Is 0 bigger than 5 minus 0 over 2, which that cancels? Is 0 bigger than 5? Is that true or false? And that would be a false statement. So again, if it's false, you don't shade the side of the line that that point's on. Instead, we're going to shade the other side of the line, and everything above the line should work. Any point, if you plug it in for x and y, should work in this inequality. Okay, let's graph this one. Y is greater than or equal to -6. Again, y is by itself. The y-intercept is -6. So from 0, 0, we're going to go down 6. 6. And here there's, the slope is 0, 0x. So if the slope is 0, you go up 0, but you can go over. So what happens is we can just keep going over, and we're going to have a horizontal line. So a y line is a horizontal line. And we look at the inequality. It is an equal sign, so our line is solid. What it means is our answer can be on this line right here. And we want to shade where y is bigger than or equal to -6. Again, where y is bigger, then it's going to be above the line, but if you want to pick a point to test, you can plug in 0, 0, but here you're only plugging in the y value. Is 0 greater than or equal to -6? And that's true, so we're going to shade above the line. For these, the ones with just x or y, you really only have to test the one pointer. Just think, where is y bigger than? -6 is going to be above the line. Okay, and then we have graph x is less than 4. So we have to graph where is x equal to 4? And x is equal to 4 if you start at 0, 0 and go over 4. And just any point on this line right here, x is equal to 4 on that line. Now we look at drawing the line. There's not an equal sign there, so it's going to be a dashed line because our answer can't be on the line. And we want to shade where x is smaller than or less than 4. So again, you can pick the point to test, or just think about, is 0 less than 4? That's true, so we're going to shade everything to the left of the line. Here's, any of these points are less than 4. So here's how you graph, again, when y is by itself. It's, you graph your slope, your y-intercept, you pick a point, test, and shade, and you shade where it's, the answer is true. So if it's false, you shade the other side. But what about that basketball problem that we did with Calvin, or this problem right here where y is not by itself? Now we did practice earlier on in the unit, if y is not by itself, you can algebraically get y by itself, but there's another way to do that. And so in order to solve that, just ask yourself, how many points do you need to graph a line? And you only need 2 points to graph a line if it's, a line straight. So the question then is, what would be an easy number to input to find an output? And again, the answer is 0. 0 is always going to be pretty easy to plug in because you get zeros and then things cancel out and then it's easier to solve. So if it's in this form, again, it's called standard form when x and y are on the same side here. Ax plus by is greater than or equal to c. So this is standard form when x and y are on the same side. You can use something called the cover-up method, which is essentially you're plugging in a point, solving, getting one answer, and then you're plugging in a point, solving for this other point, getting an answer, and then you have 2 points to solve. And disclaimer, you can only use this if your line is not on 0, 0, because then you would have to test like at least one other point that's not on the line. So we can only do this if our line is not, or if c is not 0. Okay, so let's look at the first one. Let's graph -2x plus 3y is greater than or equal to 12. Again, we could get y by itself and graph it with slope and y-intercept, or we could just find 2 points to graph. So the first one that we're going to graph is, let's say the input x equals 0. Let's solve for y. So if x equals 0, imagine covering it up. And the reason why you can just cover it up is because -2 times 0 is just 0. So we cover this up, so that's why it's called the cover-up method. And we'll say, all right, what if 3y was equal to 12? What would y have to equal? So we would divide by 3, and we would get y equals 4. So 1 point on this line is 0. All right, so I'm going to graph that 0, 4 means you just go up to 4, and there's one of 2 points that we need. Okay, so that was the first thing that we covered up. Now, let's input y equals 0. So here's our second step. What if y equals 0? Again, we're going to cover it up. 3 times 0 is 0. We just cover it up. And then we can say, all right, what's left over? -2x. When does that equal 12? And again, we'll just divide each side by -2 to get x by itself. And we would get -6. So another point would be -6, 0. And that would be another point on our line. So -6. You go 6 to the left and 0 up. Whoops. 6. Okay, now we have 2 points on the line, and the rest of the steps are the same as we did before. Is it solid or dashed? You look at the inequality. Here it is equal to the line, so we can have a solid line right here. And then you pick a point, test, and shade. My line's not very straight. And again, an easy point to test is 0, 0. So we want to see, is this true? If it's true, we'll shade that side of the line. And if it's false, you shade the other side of the line. So when we plug in 0, 0, what happens is -2 times 0 is 0. 3 times 0 is 0. So we're checking, is 0 greater than or equal to 12? Oops, I put 15. And this is false, right? 0 is not bigger than 12. So we don't shade this side of the line. These answers aren't true. Instead, any point above the line or on the line will work in this inequality. So there are all the answers in the shaded region or on the line. All right, so let's practice this cover-up method 3 more times. And then today is just, can you graph and solve the inequality by graphing? All right, so let's try this one. Again, we'll use the cover-up method. to solve. So let's say first x equals 0. Then you're looking at 4y. Let's set that equal to 8 and solve. Divide by 4, so y equals 2. So one of our points is 0, 2. We'll make a dot. Oopsies. Okay, let's plug in another point. Let's say that y is 0. If y is 0, we cover this up and we get negative x. Let's set that equal to 8. This is like an invisible negative 1. X equals 8, so we'll divide by negative 1. So we get x equals negative 8. All right, so we're going to go over negative 8 and up 0, because this is the point negative 8, 0, and graph it. All right, we got 2 points. We can graph the inequality. So let's take a look at, should this be solid or dashed? And you don't have an equal sign, so we have to use a solid line. And then we pick a point, test, and shade. An easy point to pick is, if it's not on the line, is 0, 0. So if you plug in 0 plus 4 times 0, 0, is 0 bigger than 8? And that's false. If it was true, we would shade this side of the line, but since it's false, we're going to shade the other side of the line. And what that means is any answer above the line will work in the inequality and be true. All right, let's try the next one. X plus y equals 3. Let's say x equals 0. We'll cover it up and then make an equation. Oh, and this one's easy because it's just y equals 3. So we'll graph where y equals 3, and there's our first point. Okay, so now let's cover up, let's say y equals 0, so let's cover that up, make an equation, x equals 3. So we'll go over where x equals 3 and make a line, or a dot. And now we have 2 points, so we can, oopsies. So now we can graph the line and we'll take a look, is there an equal sign? There is, and if there's an equal sign, our line will be solid. So there's our solid line. And then we pick a point, test, and shade. This is where it's less than or equal to 3. So we'll plug in 0, 0. I'm going to guess that we're going to shade below the line. So 0 plus 0, is that less than or equal to 3? And this is true. And since it's true, we shade the side of the line that 0, 0 is on. And what that means is any point below the line or on the line, I should have shaded like this area too, will work in the inequality. And our last one, again, since x and y are on the same side, standard form, let's cover one up and solve. So let's say x equals 0. We cover up the 2x. We can make an equation, 5, y equals 10. We'll divide each side by 5, so y equals 2. 1, 2. There's our first point. Okay, let's say y equals 0. Whoop. We'll cover that up, and we get 2x equals 10 if we make an equation. Divide by 2, so x equals 5. All right, we got 2 points. We can draw a line. Take a look at the inequality. There is not an equal sign, so it means our line has to be dashed. And then we have to pick a point, test, and shade. We want to know where this is less than 10. I would guess below because it's less than, but we can pick a point and test it. So 0, 0 is not on the line. We can test it. If 0, 0 was on the line, we would have to pick a point above or below the line. All right, let's plug in. 2 times 0, 0. 5 times 0, 0. Is that less than 10? And that's true. So since it's true, we shade the side of the line that 0, 0 is on. And what it means is any point below this line will be true in the inequality and will work. So our answers lie below the line. So your assignment then is the next 2 pages. The first page, it's already solved for y, so you just use the slope and the y-intercept and solve. The second page, you can use the cover-up method, and unless you like solving for y, and solve those as well. And then you have 1 word problem. So finish that for tomorrow, and we'll go over any questions.